Nonparametric regression. Nonparametric covers a lot of different types, but here we'll talk about a few of the basics. When you do OLS, estimate the expected value of y given x, with a restriction that the true estimate is a linear function of the x variables. In quantile regression, we estimate the expected quantile of y given x, with the assumption that it's a linear function of x. In OLS, we talked about stuffing nonlinearities into a linear model by adding different polynomial terms. But what if we wanted to estimate more, the expected value of y given x without the constraint of being linear, or even polynomial? We still need to assume it's smooth, but that's all. There's a trade-off. We need more data in order to relax our assumptions about the functional form. We want to let the data speak, but we need a lot of data for that. And the data are genuinely rich. There's tremendous variation. So when we estimate the averages, we're compressing down a lot of it. Here I've plotted the PDF of wages for different age groups, people who got a college degree. Can see the lightest lines, the youngest, are really bunched together down at low levels of wage, but then older groups have more variation across a much wider range. Trying to fit a linear model to what happens to the average wage as people get older? You can do that, but it's shedding a lot off. Well, how do we do the estimation? Surprise, there's a package in R, NP. So here I restrict to just people with a bachelor's degree, take a random subset of them. It's got to be small or else it crashes my computer. This tries a lot of different polynomials and reports which ones worked best. Obviously, p-values ain't going to work here since the computer was searching for the lowest possible p-value. It's no longer making a valid hypothesis test. Another version is LOES, not the soil, local estimation. This works within a localization for each y and estimates a variety of smooth functions. It's not quite as computationally complex as the earlier nonparametric regression. You can learn more from Cosma Shalizi's book, Advanced Data Analysis from an Elementary Point of View. LOES is similar to the spline, estimating polynomial functions over small intervals, but with the restriction that polynomial functions are continuous between those intervals at what are called the knots of the spline. The tuning parameter is how many knots you have. One knot cuts into two groups, two knots cuts into three groups, etc. I don't know why knots cut. I mean, the metaphor just ain't working, but whatever, that's what it is. Sorry. A GAM, a generalized additive model, does splines for a lot of the x variables all at once. Now, if you were to step just into the generalized additive model, you'd think it seems so complicated, but actually it's just piling on a whole bunch of simple stuff. We've gone through each of the steps, such as polynomial estimation, so it's just combining together some of the stuff we've seen before. So often these techniques can seem really complicated, maybe get a fancy name too, but they're actually pretty straightforward. You do some simple stuff a whole bunch of different ways or different times, and it ends up seeming really complicated and fancy. But there's nothing mind-blowing. You can do it too.